Hi, it's Anonymous, and today we're going to talk about equations. So an equation is simply a set of two expressions that are equal to each other. For example, x minus 10 is an expression. 4 we can also call constant, in this case being expressed as an expression. And now that we have two expressions, x minus 10 equal 4, we can then solve for our variable x. In order to do so, add 10 to both sides. And in order to isolate this variable x, at which point we will have x is equal to 14. Now, if you don't believe me and you would like to check, what we can simply do is plug x back into the original equation. Then we will have 14 minus 10. And what's 14 minus 10? 4. So that's an equation, and that's one way to check it. Now, this is solving an equation using subtraction and addition. However, we can also solve equations by using multiplication or division. For example, 13 equals negative 2y. Alright. We then divide both sides by negative 2 to isolate the y. So then we get negative 13 over 2 is equal to y. Negative 13 over 2 can also be expressed as negative 6.5, once again equal to y. So that's an example of solving an equation by using addition or subtraction, multiplication or division. Yeah, let's see. Let's say we have some random equation. We talked about powers and exponents, so we should be able to talk about this equation I'm about to show you. So we have x squared plus 5x minus 8 equals 0. How do we solve that one? Well, this is alluding to a future video, but just good to know, because using the rules we've learned, we can actually solve this. We'll just use a different formula, a different method. So there's this thing called factoring, and with this equation, we're not exactly able to do that yet, so I'll explain factoring in a different video. So what we'll have to do is use this thing called the quadratic formula, which simply says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And at this point you may be thinking, okay, where does the a, b, and c come from? Well, quadratic equation can actually be expressed as ax squared plus bx plus c. Therefore, simply looking at our term, of course, whenever you see any variable or regardless of its power, if it's just by itself, like x squared, y squared, z squared, or whatever, then that means that there is a 1 hidden in front of it, because 1x squared is the same as x squared. So that means we have a is equal to 1, so ax squared. Then we have bx, so therefore b is equal to 5. Then we have plus c, so that would be c is equal to negative 8, because plus negative 8 equals negative 8. So now that we have a, b, and c, we can then plug these constants back into quadratic formula. Then we'll have, so yeah, quadratic formula, x equals -5 plus or minus the square root of 5 squared minus 4 times a times c. All right, so we have x equals -5 plus or minus the square root of 25, and then 4 times 8 is 32, plus 32, because negative times negative is a positive. So at this point, all right, we have x equals, and you see one thing I'm forgetting to do, divide by 2a, divide by 2, divide by 2, don't forget that. So now we have x is equal to -5 plus or minus the square root of 25 plus 32 is 57. Right? Yes, all over 2. So that's interesting, right? In this case, we have x equals -5 plus square root of 57 over 2, and we have x, let's move that so you can actually see, equals -5 minus square root of 57 over 2. Alright, so yeah, that was a break, but I verified that the answer is x equals -5 plus square root of 57 over 2, and x equals -5 minus square root of 57 over 2. And you could plug both these values for x back into our original equation, and you'll get 0. So this is our solution set. Solution set is just a set of all solutions. So thank you for coming with me on this ride where we learned about equations, whether solving for them by addition, subtraction, or multiplication and division. We also even got an equation where we had to use the quadratic formula. So it's been anonymous. Thanks.